Welcome back to a new video lecture, and in this lecture we will discuss a very new topic called Kani'S method. And in this lecture we will discuss about what are the applications of this Kani'S method, then the derivation part related with the Kani'S equation. Then actually what do you mean by this Kani'S method, or what is the importance of this Kani'S method? Actually we know that for the analysis of indeterminate structures we are using different approaches like force method and displacement method, and we already studied some of the methods related with the force like three moment equation, then strain energy method, and in the case of displacement method we know that slope deflection equation, then moment distribution method, and one more method that is called Kani'S method that we will discuss in this module. Okay, Kani'S method. Okay, then coming to the application level, here also we can use this method for analysis of continuous beams, frames, likewise. And apart from that, we can use this method for multi-storied frames to find out the bending moment, shear force, and we can use this method for the analysis of multi-storied frames. That is the main advantage of this Kani'S method. Okay, so now we will move on to the next, that is for the derivation part. With the help of a diagram, you can observe here that a multi-storied frame is given, and let us take a point from this multi-storied frames, that is, let us take a point A, and here from this diagram you can observe that this joint A is connected to B, then C and D and E. So you can take these points, these sections, that is AB, AC, AD and AE. And also you can note down a statement from this. While doing problems you will get more clarity regarding this statement. One of the main advantage of this method is that even if some mistakes are committed in the distribution process in one cycle, it will converge to the final answer on the coming cycles. Like moment distribution method, here also we are following some iteration process. So in the initial case, in the first cycle, if you committed some minute mistakes, which will converge to the final answer correctly. That is the statement. Okay. So now we will move on to the derivation part. That is, here you can assume, or from this section, multi-storied frame section, you can take a point A, and these points are connected to AE, AB and AC and AD. And after that you have to apply the moment slope deflection equation. That is, already we know that if you are taking this MAB section, that is M of AB plus 2EIAB divided by LAB multiplied by 2 theta A plus theta B minus 3 delta LAB. So similarly you can apply to the rest of the members, that is AB, AC, AD and AE. So very easily you can apply this equation to each span lengths, that is for AB, AC, AD and AE. And now you have to consider some terms like I and J. Okay, so I represents near end and J represents far end. What do you mean by this I and J from this sections? If you are taking a section A and this is B, and you are going to take MAB, then this I will represents A and this J will represents B. Means this I is near end and this B is, or J is, the far end. That is the representation. So you can replace these four equations by this way, that is M of Ij equals M of Ij plus 2 Eij by Lij multiplied by 2 theta I plus theta j minus 3 delta Lij. This is the general statement. Okay. Then after that you have to expand that equation. If you expand those equations, you will get, if you elaborate those equations, Mij will be equal to M of Ij plus if you multiply those or bracket to be open, you will get 4eij by lij multiplied theta I plus 2eij by lij plus multiplied by theta j minus 6eij by lij multiplied delta by lij. Okay, if you open up those brackets, you will get this equation. After that, you can represent this term and this term and this term in this format, that is m of ij will be equal to 2eij by lij multiplied by theta a. You are taking 2 multiplied by 2 from this 4. Okay, then this 2 eij, this term will be, you can represent it by mij, and here also you can represent this whole equation by mji. Okay, and this can be represented as m dash ij. This is a representation. Okay, so please note down this. I represents the near end, then j represents the far end. So you can again replace the equation as capital Mij equals capital M of ij plus 2Mij plus Mji minus M dash ij. And here all the terminologies are given here, like Mij represents a rotation contribution of near end, then Mji represents far end, then last one, it is related with the displacement contribution, that is ij. We already know that it is related with this delta component is there, so it already mentioned the displacement contribution. Okay, then after that, we already know that in that multi-storied frame, that joint, if you are taking that multi-storied frame, if you are taking that particular joint A, the summation of moment about this point will be equal to 0. So you can note down this statement, the summation of moment will be about those point will be 0. So sigma or MAB plus MAC plus MAD plus MAE equal to 0 if you take the summation of moments about that particular point A. Then again you can note down this equation or represent those equation with the terms as I and J, that is sigma Mij equals sigma MFij plus 2Mij plus Mgi minus M dash ij. So you can represent this equation as number 2. With the terms as I and j, we replace this equation, this general equation. Okay, so we already know that the summation of moment about that particular point is equal to 0. So if we equate this value to 0, and for the derivation part, we will write down this equation in this format, that is taking this 2 to this side to right side, and that is minus 1 by 2 multiplied sigma m of ij plus mji minus m dash ij. So this is your next equation. And also note down that we already determined this statement, that is Mij equal to 2eij divided by lij multiplied by theta I. Already we determined the previous slide. And if you can write down this equation in this way, okay, that is taking this or writing this 1 by 2 multiplied by 4, this value is same, okay, just a representation, that is 1 by 2 multiplied by 4eij divided by lij multiplied by theta. Okay, if you write down that equation in that format, you can note down another relation, that is we already know that this k, if the far end is fixed, we know that it is going to be 4ei by L, and you can replace this equation in this format, that is Mij equals kij theta I by 2. Okay, that is a important step you have to follow. Please check out this equation once again, that is we are replacing this term, that is we are replacing this term 4ei by L with kij. So kij theta I by 2 will occur. So here you can visualize that sigma Mij, if you are taking the moment, summation of moment, sigma kij theta I by 2, that is equation number 2. And if you are taking this equation 3 and 4, if you divide both the equation 3 and equation 4, you can easily observe that Mij equal to Kij by sigma Kij multiplied by sigma Mij. So this is the equation number 5. Okay. So now we will move on to the last step, that is you can substitute those values. Here you can observe that substitute equation 2a in equation number 5. So please observe equation number 5 and equation number 2a. So here you are going to apply that equation. So here you can observe that you are going to apply those values as, that is Mij, we are going to apply equation 2a in equation number 5. So Mij equals Kij by sigma Kij, then multiplied by this value, applying these values. So if you write down this equation in this way, that is minus half multiplied by Kij by sigma Kij, then this terms is here, and here this is our important value, that is minus half multiplied Kij by sigma Kij, that is the rotation factor. Okay, so that is the most important statement from this equation. This rotation factor will be equals minus half multiplied by Kij by sigma Kij. Already we know that in the moment distribution method, that is the distribution factor will be K by sigma K, and here we will multiply by minus 1 by 2. That is only difference. Okay, that is minus half multiplied K by sigma K. So again you can represent this equation in this format, that is rotation factor can be represented by Rij, then sigma mfij plus mji minus m dash ij. This is the equation. So here you can state that the final statement, that final moment equal to rotation factor, that is Rij, multiplied by summation of this fixed end moment of the near end, that is Ij, then rotation contribution of far end, that is Mji, minus this displacement contribution, that is of the near end, that is M dash Ij. Okay, that is the final statement. And here also you can note down a statement that you can also write down this rotation contribution of far end equal to 2 multiplied by rotation contribution of near end. That is, you can write down this Mji as 2Mij. Okay, so this is also a condition. So this is the statement for the final statement for this Kani'S method. So while doing problems, you will get more clarity regarding how to apply these equations and what is importance of this rotation factor, like all terms. So I hope this section is very clear to you, and with this we will wind up today's section. So thank you.